In radiometry, radiant energy is the energy of electromagnetic radiation. The SI unit of radiant energy is the joule. The quantity of radiant energy may be calculated by integrating radiant flux with respect to time. The symbol QE is often used throughout literature to denote radiant energy. In branches of physics other than radiometry, electromagnetic energy is referred to using E or W. The term is used particularly when electromagnetic radiation is emitted by a source into the surrounding environment. This radiation may be visible or invisible to the human eye. Terminology, use and history. The term radiant energy is most commonly used in the fields of radiometry, solar energy, heating and lighting, but is also sometimes used in other fields. In modern applications involving transmission of power from one location to another, radiant energy is sometimes used to refer to the electromagnetic waves themselves, rather than their energy. In the past, the term electro-radiant energy has also been used. Analysis. Alternatively, EM radiation can be viewed as an electromagnetic wave which carries energy in its oscillating electric and magnetic fields. These two views are completely equivalent and are reconciled to one another in quantum field theory. EM radiation can have various frequencies. In the photon picture, the energy carried by each photon is proportional to its frequency. In the wave picture, the energy of a monochromatic wave is proportional to its intensity. This implies that if two EM waves have the same intensity, but different frequencies, the one with the higher frequency contains fewer photons, since each photon is more energetic. When EM waves are absorbed by an object, the energy of the waves is converted to heat. This is a very familiar effect, since sunlight warms surfaces that it irradiates. Often this phenomenon is associated particularly with infrared radiation, but any kind of electromagnetic radiation will warm an object that absorbs it. EM waves can also be reflected or scattered, in which case their energy is redirected or redistributed as well. Open systems. Radiant energy is one of the mechanisms by which energy can enter or leave an open system. Such a system can be man-made, such as a solar energy collector, or natural, such as the Earth's atmosphere. In geophysics, most atmospheric gases, including the greenhouse gases, allow the sun's short-wavelength radiant energy to pass through to the Earth's surface, heating the ground and oceans. The absorbed solar energy is partly re-emitted as longer wavelength radiation, some of which is absorbed by the atmospheric greenhouse gases. Radiant energy is produced in the sun as a result of nuclear fusion. Applications. Radiant energy is used for radiant heating. It can be generated electrically by infrared lamps, or can be absorbed from sunlight and used to heat water. The heat energy is emitted from a warm element and warms people and other objects in rooms rather than directly heating the air. Because of this, the air temperature may be lower than in a conventionally heated building, even though the room appears just as comfortable. Various other applications of radiant energy have been devised. These include treatment and inspection, separating and sorting, medium of control, medium of communication. Many of these applications involve a source of radiant energy and a detector that responds to that radiation and provides a signal representing some characteristic of the radiation. Radiant energy detectors produce responses to incident radiant energy either as an increase or decrease in electric potential or current flow or some other perceivable change, such as exposure of photographic film. One of the earliest wireless telephones to be based on radiant energy was invented by Nikola Tesla. The device used transmitters and receivers whose resonances were tuned to the same frequency, allowing communication between them. In 1916, he recounted an experiment he had done in 1896. He recalled that, whenever I received the effects of a transmitter, one of the simplest ways to detect the wireless transmissions was to apply a magnetic field to currents generated in a conductor, and when I did so, the low frequency gave audible notes. SI radiometry units. SI radiometry units V. T. E. Standards organizations recommend that radiometric quantities should be denoted with suffix E to avoid confusion with photometric or photon quantities. ABCDE alternative symbols sometimes seen. W or E for radiant energy, P or F for radiant flux, I for irradiance, W for radiant excitance. ABCDEFG spectral quantities given per unit frequency are denoted with suffix nu, not to be confused with suffix V, indicating the photometric quantity. ABCDEFG spectral quantities given per unit wavelength are denoted with suffix lambda. AB directional quantities are denoted with suffix omega.